Hello, welcome back to our channel. Today we are going to discuss about laws of motion crash course. In this first we are going through the what are the Newton's three laws. What is the Newton's first law? The body will continue to its state of rest or state of uniform motion unless we are applying the external force. That is called what? Newton's first law. Can you give any example for that? Look here, this board is here. Okay, tomorrow also it is here only, day after tomorrow also here it is here only. Unless I am not disturbing this, it will continue its state of rest. Like that, earth is revolving around the sun. Unless there is no disturbance, earth is always revolving around the sun. So here we are taking two cases. One is the at rest and at uniform motion. Both are we are treating as a single condition like that. So this is the Newton's first law. But what it gives? It gives the concept of inertia. What is inertia? Inability to change the state of rest or uniform motion. Suppose one big stone is there and one small stone is there. Which is having more inertia? Big stone is having more inertia. We require more force to change its state of rest. So that is having the more inertia. So simply you can say that mass is the measurement of inertia. But inertias are three types. First one is the inertia of rest, inertia of motion and inertia of direction. What is the inertia of rest? Suppose one bus is at rest condition. When the driver starts that bus, immediately the passengers feel sudden jerk like that. Still they want to continue their state of rest, but he starts that bus. At that time, that is called the inertia of rest. Then where we should observe inertia of motion? When bus is starting and it is moving, when he applies sudden brake, we feel sudden jerk because of the inertia of motion. When the bus is turns right, we fall left, that is called the inertia of direction. So this is about the inertia. Then we are going to discuss about what is the momentum. Quantity of motion is called the momentum. Momentum, what is the formula? Momentum is quantity of motion. It is the product of mass and velocity. And you remember that it is a scalar quantity. It is a vector quantity. It is a vector quantity. Unit is kg meter per second and dimensional formula is mlt power minus 1. This is about this one. This is called the momentum. Quantity of motion is called the momentum. Then we are going to discuss about the force. Just it is the reverse of that inertia. Ability to change the state of rest or uniform motion. That is called the force. But how many basic forces are there in nature? There are four types of basic forces are there in nature. What are those? One is the gravitational force, electromagnetic force, weak and strong nuclear forces. These are the forces. But how to calculate the force? Now we know the definition for the force. But how to calculate the force? Suppose momentum is there. When we are doing mass into velocity, we can able to find out the momentum. Like that, how to calculate the force? It was explained by the Newton only, but it is called the Newton's second law. So what is the Newton's second law? He given the relation between momentum and force. F is equals to rate of change of momentum. F is equals to rate of change of momentum. But just now you know that instead of mass into momentum, we should write it mass into velocity. So this is the mass into velocity. Now it is, we are dividing into two wings. Look here. First one is if m is constant. Generally we can say that m is constant, means differentiation we can't apply to the mass. So m into dv by dt. So it should be right mass into acceleration. Generally, what is the formula for force? Means many people they are using force equals to mass into acceleration. Then what is the unit for force? Unit for force is it was introduced by Newton. That's why we are taking Newton. And dimensional formula is mlt power minus 2. And you remember that it is a vector. It is also vector quantity. It is also vector quantity. So when you suppose mass is 4 kgs, acceleration is 10. What is the force? 4 into 10, 40 newtons. Like that we can able to find out the force. And you remember that for the force there are many units. In SI system we are taking the Newton. In CGS system that is the dyne. What is that relation? 1 Newton equals to 10 to the power of 5 dynes. Like that, 1 dyne equals to 10 to the power of minus 5 Newton, like that. Suppose if m equals to 40 grams and acceleration equals to 2 centimeter per second square, then what is the formula in this? F equals to, say, mass into acceleration. 40 into 2, how much? 80. But this is in grams and this is in centimeters per second square, means we are getting in dynes. Then F equals to, we should write it 80 into 10 to the power of minus 7 newtons also we can apply. So unit is playing an important role. You must remember that 1 Newton equals to 10 to the power of 5 times. And one more unit is there, that is the, suppose we are taking 2 kg weight or 2 kg force, means we are expressing that is SI system only, but kg force means like we should multiply here 9.8 newtons. Like that, 1 gram weight or gram force means we are multiplying with 980. So this is in CGS system and this is in SI system. These are the units of the force. Then come to here, don't stick only for force equals to mass into acceleration. You know that previous cases, what is acceleration? Change in velocity by time is called the acceleration. When you know the mass and acceleration directly, we can use this one. Suppose we know the initial velocity and final velocity and time, we can use this one. If we know the initial velocity and final velocity and distance, instead of A, we are writing v square minus u square by 2s. See how many formulas are there. It is in terms of momentum. It is in terms of acceleration. This is in terms of change in velocity and time. This is in terms of distance and velocities. Like that, where we are using when mass is constant, means mass is not changing with respect to time. Then come to another part. If V is constant, then what is the expression for force? F equals to V into dm by dt. From this, what you are understanding? Mass is changing with respect to time. Mass is changing with respect to time. Suppose that cement mixture truck is there. There what happens? That is rotating with constant velocity. We are adding water, sand, that cement, stones and all this. So time to time, which is changing? Mass is changing. In this case, velocity is constant. Not only this one, one conveyor belt is there. So we are adding that pouch, purses at metro and all this. That is going on like this. There which is changing? Velocity is constant. But depends on the person carrying the weight, that mass is changing. So at that time, how to calculate the force? We can take it V into dm by dt. One problem also I am saying here, look here. If F equals to 10 newtons, V equals to 2 meters per second, find m by t. M by t equals to how much? Don't think it is changing like that. So a mass per time means you can take it F by V only. F is the 10 newtons and velocity is the 2. So answer is 5 kg per second. 5 kg per second. So this is in the case of variation of mass. This is in the case of variation of velocity, and it is belongs to kg force, gram force we are applying. How to convert this one we can take. Here we are multiplying with acceleration due to gravity 980 meter per second, centimeter per second square. This is the 9.8 meter per second square. So this is about the Newton's second law. Finally, what is the use of that Newton's second law? With the help of that, we are getting the expression for force and we can able to calculate the force. And it is belongs to Newton's second law. Then we are going to discuss about what is the law of conservation of linear momentum. Before that, we can go through the impulse. Impulse is represented by J or I also they are taking. A large force is acting. In short interval of time. A large force is acting in short interval of time is called what? Impulse. Look here. What is the example? When the ball is hit by the bat. So a large force is acting on the ball. that too in fraction of seconds. That is called the impulse. Impulse formula is, look here, force into time. When you know the force and time, instead of force, mass into acceleration into time. Instead of acceleration, when you know that velocities, this dt cancel. We can write it mv minus mu. This is the change in momentum, delta p also. Finally, you look here, this is force into time. This is change in momentum also, we can say that impulse. So what is the unit for impulse? You remember that it is a vector quantity. It is a vector. Unit is how much? Same, kg meter per second. Then the dimension formula is what? ml t power minus 1. This is that. But now look here, our problems are like this. This is one graph. On x-axis we are taking time. On y-axis we are taking force. This is like this. Here 0, 2 and here 4 newtons. This is 2 seconds. Find impulse. Means what we are taking? This is area under multiplication. So impulse is the force into time. If we want force and time, impulse means area under force and time is giving what? Impulse. But that too, this is which geometrical shape? Triangle. Triangle, what is the area? Half into base into height. So we can take it. Base is how much? 2. Then height is how much? 4 newtons. After that, this is 4 kg meter per second. Like that we can calculate. Not only this one more problem we are doing based on the Newton's second law. If P equals to 4t square plus 2t plus 6, find force at t equals to 1 second. Then immediately we have to use which formula? Force formula only. Because force equals to rate of change of momentum, d by dt of P. So do the differentiation. 4 into differentiation of t square is the 2t. Differentiation of t is the 1. Differentiation of 6 equals to constant. It is not changing with respect to time. This is value is 0. Finally, you are getting 8t plus 2. But instead of t, we are taking 1 second. So our answer is how much? 10 newtons. So with the help of the differentiation, we can able to find out the force, and with the help of the graph also, force and time, we can find out the impulse also. And one more thing, what are the applications of the impulse? While catching the ball, we are lowering our hands towards ourselves. Why we are lowering our hands? What is the relation? See, look here. If J is constant, means impulse is constant. What is the relation between force and time? Force into time equals to constant. You can say that force is inversely proportional to time. When we are lowering our hands towards ourselves, we are increasing the time. When the time is increasing, we can reduce the force. Not only this one, in vehicles also, they are using the shock absorbers. Even they are going uneven road. Immediately the force is acting on the vehicle, but because of the shock absorbers, these are increasing the time. We will get the less hurt because of the shock absorbers. Like that, when the person is falls on the cement road and on sand, who is getting more injuries? Those who are falling on the cement road. Immediately he will get the hurt because there is no time lapse in that case. So all belongs to applications of the impulse. Why we can say that this is force is inversely proportional to time. One simple problem also we are doing. F1 equals to 10 newtons. F2 equals to 20 newtons, T1 equals to 2 seconds. How to find out the T2? Immediately you can go through the F1 by F2 equals to T2 by T1. Both are inversely proportional to each other. 10 by 20 equals to T2 by 2. So this is the 10, 10 cancel. Our answer is how much? T2 equals to 1 second. This is about the impulse. Now we are going to discuss about law of conservation of linear momentum. What is the law of conservation of linear momentum? If there is no external force acting on the body, then you can say immediately momentum is constant. Momentum is constant. When momentum is constant, we can say that what is the relation between mass and velocity also. This is called the, look here, law of conservation of linear momentum. So directly you can take it, F equals to 0. When f equals to 0, you know that from the Newton's second law, dp by dt. When f is 0, you can write it dp by dt equals to 0. What is the meaning for this? Momentum is not changing with respect to time, means p equals to constant. But instead of p, we are writing mass into velocity equals to constant. Then can you say what is the relation between mass and velocity? Mass is inversely proportional to velocity. It should be right m1 by m2 equals to v2 by v1. v2 by v1. Suppose one car is there, one bus is there. Okay, generally which mass is more? Bus mass is more. If the momentum is same for the bus also, like 40 kg meter per second, and for the car also 40 kg meter per second. But here, which is having more velocity, means what do you say? Car is having more velocity. Less mass, more velocity. More mass, less velocity. When? Not at all conditions, at momentum is constant. You can give that relation. M is inversely proportional to V. Not only this one, in the case of firing of the bullets. So you know that when the bullet is going forward direction, gun is coming backward direction. Why it happens? From the law of conservation of linear momentum. See, before firing and after firing, momentum is same. Before firing, both are at rest condition, means momentum equals to 0. After firing, mass of the bullet into velocity of the bullet. This is the momentum of the bullet. Then this is the momentum of the gun. After that, look here, mg/vg equals to minus mb/vb. That's why from the law of conservation of linear momentum, we can say that both are having the opposite direction. Not only this one, in the case of explosion of the bomb. In the case of explosion of the bomb, look here, one bomb is there. Initially at rest, means what is the momentum? 0. But after explosion, suppose it is having the two parts, it is splitting into two parts. What we are taking? m1 v1 plus m2 v2. Here we can say that m1 v1 equals to minus m2 v2. This is in the case of two parts. And many people, they are asking the doubts, not two parts. Suppose three parts are there. How to simplify this one? Look here. Now this bomb explodes into, this is the P1, this is the P2, this is the P3. So how many pieces are there? 3 pieces are there. Anyway, before explosion, what is the momentum? Momentum equals to 0. Then after explosion, P1 plus P2 plus P3. Suppose we want to find out the P3. Magnitude of P3 equals to, otherwise we can write it P3 equals to minus P1 plus P2. Suppose in the question find the magnitude of this one, means mod of P3 equals to mod of P1 plus P2. Just now I said momentum is the vector quantity. Suppose in this case P1 equals to 3, P2 equals to 4, theta equals to 60 degrees. Means between P1 and P2 they are giving the 60 degrees. Then how to find out the P3 with the help of this? From the parallelogram law of addition of vectors. We can go through the P1 square plus P2 square plus 2P1 P2 cos theta. Substitute all values, you are getting under root 9 plus 16 plus 2 into 3 into 4 into 1 by 2 cos 60. After simplification, P3 equals to how much? 25 plus 12. 25 plus 12, you are getting 37. Unit is kg meter per second. Like that, simply we can go through the parallelogram law of addition of vectors and we can able to find out the resultant momentum or third particle momentum or first particle momentum based on the given data. So this is belongs to law of conservation of linear momentum. Not only this one, based on this many questions are there. Look, many applications based on this. Just now we know that finally we are writing force equals to change in momentum by time. Change in momentum means we can write it m into v minus u by t. Look here, one ball is there. The ball is striking this with how much velocity u, and it comes back with another velocity v. Here force equals to what we are writing? Change in momentum, m into final velocity how much? Minus v, initial velocity is minus u. This is the time. Simply we should write it m into v plus u by t. So in this, suppose they are asking only magnitude of the force, means simply you can write it m into v plus u by t. Understanding both are having the opposite direction, that's why we are adding here. Like that, in this case, if u equals to v, what you are getting magnitude of the force m into u plus u, how much? 2u by t. 2u by t. See, do one example also. If v equals to 4 meters per second, then u equals to 2 meters per second. Time is the 4 seconds. How to find out the force in this case, first case? So m into, m is the 2 kgs. M into v plus u is the 6 by 4. Answer is how much? 3 newtons. Got the clarity? Here ball is striking the wall and it comes back. So we can add that one because both are having the opposite direction. Not only this one, look, this case, this is the wall. If the ball is coming and striking, it will make an angle theta. In this case, that force, magnitude of the force what we are taking, here we can take the cos theta. So velocities are same. Simply you can write it 2m, instead of u we are taking cos theta by t. Cos theta by t. Like that, another case, if the ball is striking the wall, it will make an angle theta with the vertical. So in this case, instead of cos theta, we are taking the 2mu sin theta. 2mu sin theta by t, like that. Not only this one, look here. This is one horizontal plate. We are firing the n number of bullets. These are going and striking the plate with how much velocity? U. They are coming with same velocity, but in that time it is we are using n number of bullets. Here bullets are continuously firing. These are striking and coming back with same velocity. And why this is in horizontal? That weight is balanced by this force. So simply we can write it here F equals to n into, because n number of bullets we are using. If you are using the single bullet, we can take it n equals to 1. N number of bullets means we can go through the same m into u plus u. How much? 2mu by time. Okay, why it is balancing? Weight is balanced by this one. We can write it. This mass is suppose m. M into g equals to n into 2 into n into mu by t also we are using. This is very important case. All belongs to Newton's second law. We are saying impulse, we are saying change in momentum, we are concentrating on law of conservation of linear momentum, and we are concentrating on the force. Not only this one, we are going through the, in terms of area also we are expressing the force. Suppose especially water is coming from the pipe, we can express that formula force in terms of area also. Generally we are taking force equals to mass into acceleration. Instead of mass, we are taking volume into density into acceleration. Instead of volume, we are taking area into length into density into, this is what? Change in velocity by time. Here initial velocity we should consider 0. So now A into length equals to velocity into time to density into V by T, which is cancel, Tt cancel. So what is the formula for force here? F equals to A into V square into D. So no one will give density of water. You should remember that is 10 to the power of 3 kg meter per second. 10 to the power of 3 kg meters per second. Same, suppose this is one pipe is there. Water is coming like this. That force is directly proportional to area. Force is directly proportional to density. Force is directly proportional to V square. Not only this one, suppose this water is striking. This water is striking and coming back with same velocity. Here you can take it, the change in momentum is how much? That is simply we can take it F equals to 2AV square into D. That is impulse also we can find out, because impulse equals to force into time. So this is belongs to how to express the in terms of area and density. We do one problem also. Look here. If A equals to 4 meters square, V equals to 2 meter per second. Find the force means A into V square is how much? 4. This is water means 10 to the power of 3. So our answer is 16 into 10 to the power of 3 newtons. Like that we can find it. So all these cases belongs to Newton's second law. Then we are going to discuss about the Newton's third law. I think you like this Newton's third law. For every action there is always an equal and opposite reaction is there. So but you remember that action and reaction never act on the same body. Suppose action and reaction both are on this board, then resultant force equals to how much? 0. It's not possible. So while using that Newton's third law, you should remember that action is on one body and reaction is on another body. Suppose rocket is there, fuel is coming downwards, rocket is going forward direction. So action is on rocket, reaction is on fuel. Okay, not only that one, bullet and gun. No. Action is on bullet, reaction is on gun. So action and reaction never act on the same body. You should remember that F12 equals to minus F21, action and reaction. But this we can remember that action and reaction never act on the same body. Thank you everyone. Please subscribe my channel. And today I think we are going to discuss already 16th day I have given the plan. And few previous years problems also I have given yesterday. Follow that and try to understand the subject and don't waste the time. Minimum time you should learn from physics side. You must read 3 hours. Okay, follow one by one. Waves I have given, units and measurements I have given, electric charges and I have given from the second year. And ray optics also I have given. From the first year, units and measurements, straight line, plane and this laws of motion is the 4th chapter from the first year. So better you follow all videos, don't waste your time. Thank you everyone. Please subscribe my channel and share my channel to your friends also. I think in this moment it's very useful for you.